Scientific notation. Now there's two different forms I'm going to be talking about in this video, and that's standard form that looks like a normal number that you're used to seeing, and then scientific notation, which is most often a number with a decimal, but it doesn't have to have a decimal, and it always has times 10 to an exponent. Sorry, I clicked it faster than what I meant. Scientific notation is a way to simplify writing super large or super small numbers. When changing into scientific notation, if the number is greater than 1, then the exponent will be positive, and if it's less than 1, the exponent will be negative. So 75 million will have a positive exponent because it's greater than 1. And then the next number is definitely less than 1, so the exponent will be negative. Please pause this video and write these steps down in your notebook. Okay, let's turn these into scientific notation using the steps you just wrote down. So we want to have a decimal, and again, it doesn't have to be a decimal, but in both these scenarios, it will have a decimal, and you only want the ones place. So we're going to put our decimal right after the 7, so that 7 is your largest number, and then we have 0.5. Now we don't need to worry about all these zeros. That's going to be included as part of our scientific notation. So we're always going to write times 10, and that 10 is going to have an exponent. Since this number is greater than 1, that exponent has to be positive. And we find that number, the exponent, by figuring out how many times would I have to move this decimal in order to make it 75 million. And so if I moved it to the right 1, 2, 3, 4, 5, 6, 7 times, that gets us our exponent. Now the second example, again, we want the ones place to be our biggest place value, our largest place value. So this is going to be 5.08. Now I did have to include that 0 because I had an 8 afterwards, but I don't need to worry about all of these other zeros. Those other zeros are going to be helpful because they're going to help me figure out what exponent is on my notation. So I'm always going to write times 10, and it is going to get an exponent. It has to be negative because this number is less than 1. And we figure out what this exponent is by figuring out how many times do I have to move this decimal to get it back to my original decimal. And that's 1, 2, 3, 4, 5, 6, 7, 8 times. So it's to the negative 8 power. Okay, pause this video, try this on your own, and when you're ready to go over it together, then click play. For our first problem, we want to put our decimal right after the 5, so this is going to turn into 5.75. We don't need to worry about all those zeros. The whole purpose of that is to figure out how many times we need to move our decimal. We always have a times 10. And then if we were to move our decimal 1, 2, 3, 4, 5, 6, 7, 8, 9 times, we would get back to our original number. So we're going to write to the 9th power. It has to be positive because this number is greater than 1. Okay, problem 2. This is where we won't actually end up having a decimal in our problem. You could technically write 6.0, but you really don't need 0.0. That's like saying you're 12.0 years old. You don't need the 0.0. We're still going to write times 10, and we are going to have a negative exponent because this number is less than 1. We figure it out by finding out how many times can I move this decimal to get it back to my original number. And it would be 1, 2, 3, 4 times, so it's to the negative 4th power. Number 3, 56 million. You have to figure out what that looks like in the first place. So I have 56, and I actually need 6 zeros to get 56 million. And I'm going to use a different color. We want the ones place, so this turns into 5.6. We always need times 10. and we have to move our decimal 1, 2, 3, 4, 5, 6, 7 places. So to the 7th power. It's greater than 1, so it has to be positive. Now, if we're going the opposite direction from scientific notation to standard form, if the exponent is positive, when it says go right, it means move the decimal to the right, however many places that exponent is. And if the exponent is negative, then you're going to go left. If you think you can try this on your own, pause the video, try it on your own. If not, watch me do the first one and then pause the video and try it on your own. But we're going to go over these 4 examples. So we have 3.45, and we have a positive exponent, so I know I'm going to move it to the right. This number is going to be greater than 1. We don't want to accidentally make it less than 1. So I'm going to move it to the right 1, 2, 3, 4 places. Now, every time you see an open space, you are going to include a 0 there. Now, I do want to clean this up a little bit. So I'm going to erase this. And every time you count 3 from the right, that's when you put a comma. So this is 34,500. Number 2, we want to move that decimal to the right because it's positive, to the right 10 times. So this is going to be a really big number, and that's the whole point of scientific notation, is that we're working with really big numbers. So we're going to move it to the right 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ooh, we've got a lot of zeros we need to include here. And again, let's clean it up a little bit. Let's put a comma every time you count 3 digits from the right. So now we're in our thousands, millions, billions, 89 billion. Okay, the difference between 3 and 4 is we now have negative exponents, which means we're going to move our decimal to the left. So this number is going to be super small. So I'm actually going to write 2.2 over here. And I have to the negative 3 power. So that means I'm going to move it to the left 3 times. So I already counted 1, 2, 3. And put those 0 placeholders and put a new decimal. So this is 0.0022. Clean it up a little bit. Okay, and last one, we have 3.14, and I have to move this decimal to the left 7 times. So 1, 2, 3, 4, 5, 6, 7. Don't forget to put a new decimal place and fill in those place values. Here I'm cleaning it up by erasing my work shown, but you could just have a separate space where you could write your answers so you don't erase your work every time. And we end up getting a decimal and 6 zeros, 314.